Now let's look at another problem. Find the largest sum contiguous subarray. Contiguous means that subarray will not have any breaks. For example, we have an array 3, 1, 2, minus 9, 7, 3, and 2. The 3, 1, 2, 7, 3, 2 will be not a correct answer because we just keep minus 9. 7, 3, and 2 will be contiguous subarray and the correct answer. Now let's look at the naive approach. The simplest thing that we can do here is the technique called sliding window. We need to initialize the result with minimum value possible. Then we are going to iterate the whole array from 0 until the array size. And we need to initialize the variable for storing intermediate results. For the next loop, we will iterate it from current position I until the array size again. We need to update the intermediate sum and check if that sum is maximum. The complexity of this algorithm will be O(n) squared because we have one loop inside the other that iterates through the whole array. Let's see what unnecessary work we are doing here. We are checking the same elements here over and over, but do we really need to do it? Let's think about what kind of sub-problem we are trying to solve here. Actually, we should check if adding the current element to the array will be more productive than starting over. Let's see an example. Let's start from element 0. Ongoing sum will be 3 and maximum sum will be 3 as well. For element 1, situation will be kinda the same. Ongoing sum and max sum will be 4. For element 2, ongoing sum and max sum will be 6. And this is the place where things get interesting. For element 3, ongoing sum will be minus 3 and maximum sum still will be 6. For element 4, if we are going to add 7 to minus 3, we will get a current sum of 4, but isn't it better to take just 7 and start a new sequence? So ongoing and max sum will be 7. For element 5, it's trivial, we just add 3 and we will get tens for both variables. For the last element, we will also just add 2 and we will get our result 12. Now let's jump to optimized solution implementation. Let's initialize two variables, one for ongoing sum and the other for max sum. It should have minimum value possible. Then we are going to iterate the whole array starting from 0. We need to add current element value to the ongoing sum and check if the ongoing sum is bigger than the current element. After that, we should figure out if the current sum is the maximum sum available. And this is going to be our optimized solution with linear complexity O(n).